So we're summarizing numerical data. We've already been doing this a little bit, but I will show you now what I'm talking about on the calculator in case you haven't seen this. But when we're summarizing data, we always look at the median, the range, the IQR, which is, you're going to see down here, is Q3 minus Q1. So Q3 stands for the third quarter mark, and Q1 is the quarter mark. So we'll look at that, and then we're going to look at displaying this data in a box plot. So first of all, a few points about the median. The median is the midpoint, or the 50% of the data. So you'd have half the data before the median and half the data after. And the median is located at, so we've been writing this already, n plus 1 divided by 2 position. So that's why it's saying it's located at. It's not the actual median number, it's where you find it. And the range is obviously the maximum minus the minimum, or the smallest. And then the interquartile range is actually where 50% of the data lie. So it becomes more interesting because we don't really want to know, like, say, the first 50% and the last 50%. We want to know roughly where that middle 50% is, because that's where all the people are. That's probably what we're interested in. So the IQR shows us where the middle 50% is. Okay, why do we sometimes use the IQR? Because it's not affected, and either is the median, by outliers. So I might get you to write a little note here that the median and the IQR are resistant statistics, resistant stats. That is, they're not affected by outliers or by skewed data. So you got to remember, when you have skewed data, if you think about it, you often have this tail and there's these extreme values, or if you have it the other way, there's a few low ones, but then most of the data's up. So when you're finding the median will always come into that, will be found. You'll notice it's in the middle chunk. It's where the 50%. So that's good to use, because the mean, if you find the mean, so remember the mean is the average. The average, and this one is affected by outliers. So the way to explain it, if you say had a class here, we got all your weights, and what happened if I had a new student come in and he was about to go on The Biggest Loser? He comes in, he will make your mean so high, it's not a true indication. He won't affect your median, because you think about it, we had, say, if we had 20 kids, we put 21, it's still going to be around the middle kid who's not different, yeah? So the mean is affected. So when you have skewed data, you'll see positive. So this is positive skewed. When you see positive skewed, you'll see that the mean is higher than the median. When you have negative skewed over here, negative skewed, you'll see the mean is lower than the median. So you might just want to write that down. We often are referred to, and we like to look at, the 5-number summary. And the 5-number summary, if you're asked to write it, it has to go like this. You go 1 to 5, and you simply state what the minimum value is, the Q1, this is the median, the Q3 and the maximum. So I'm going to show you on a list how we do all this on the calculator to help you with that. All right, check. Yeah. Okay, so we can present the 5-number summary as a box plot. So here are the steps, and they're listed in your calculator for those boys who can't remember or are new to it. So we would have put the list in, and we just did that before. We gave the list a name, And then once you've got the list in, you go back to your data and spreadsheets. That's the pink little tab on your menu page. And then you select your list down here. So this one, they selected age. They had a group of ages. And then they changed the plot type. Exactly like a histogram, but you change a plot type to a box plot. And then you get your box plot drawn up. So you can see this little value will be the minimum. This one here is Q1. Then the middle line represents the median. This line represents Q3. And where the whisker ends is the maximum. Now, be careful. When you have an outlier, it looks like this little dot out here. And that is still your maximum. The furthest point is always the maximum. And then in this example, there was no lower outlier, so the minimum is just at the end of the whisker. So the calculator will automatically determine whether there's outliers or not. So you'll do that and I'll show you in a minute. But what is it doing to say that it's an outlier? And this is what you'll have to do. They'll often say, show that this number's an outlier, and you use these formulas. So you can see down here, Q3 plus 1.5 times the interquartile range. So remember, interquartile range is Q3 minus Q1. So when you do that, you end up with a number, okay? And any number higher than that is an outlier. Any number higher. Then you have a lower fence. And just take note that the lower fence is Q1 minus and then 1.5 times the IQR. So any number lower than that, you'll get a number, and any number lower is a lower outlier. So they'll ask you to prove it. It is one, and you just show this full formula with your working out the number, and then you say therefore it's lower. So I'll show you on the calculator how to get. Okay, so we were talking about box plots the other day, and we're going to continue talking about them today. But so just to summarize what we've got up to, so a box plot, when you're drawing your box plot in your SAC, you can simply copy your calculator, what the calculator's brought up. So what I need you to do is draw the ruled number line underneath, and so you'll have your lines, and you can just copy what the calculator's put down there. So we normally have them these way. So we might have like so, and you might have an outlier. What I also need you to do is actually pop in what those numbers are. So this would be the Q1, this would be the minimum, this would be the median, this one would be the Q3, and this one would be your maximum. So just pop in there what those numbers are. That way you're very clear that you've drawn what you've drawn. So if you're a little bit off with your scaling, it's nice and clear. Now we can have a parallel box plot, which means we might compare two things. So you might see another box plot using the same axes like this. And what we're going to look at today is how we interpret or compare those two when we've got two together. Now remember, an outlier, if you have this outlier up here, it's because it's above the upper fence, which we can find what that number is. So any number above that number would be an outlier, and we can also have a lower fence, and that's there. If you're asked to prove why something is an outlier, you write out that formula, show the number, and then write therefore this number is higher or lower than that and is an outlier. Okay, so let's moving on to describing our box plot. So we've looked at putting the data in and drawing up these box plots. So now we're going to talk about describing what does it show us. So we can talk about the skewness or the shape of the box plot. So if we're describing the shape, we'll talk like this. So this one here is symmetric, and what you're looking at is the actual box part. So see how this side is the same length as that side. That's what they're talking about when they talk about the shape. So you can see when you have a positive skewed box plot, you get that you get all the data. So this box is smaller than that second box there. So it's like the tail. So can you see with the histogram, you have all the data at the front and it tails out at the end. That's positive skewed. When you have the other way, the tail at the start and all the data at the end, you'll see it like this. So this first box is bigger and the second one is a little one. If you have, we've already talked about, if we have a box plot with an outlier, we'll see out here. So this one here, I would probably say it's still negative skewed because this box here is bigger than the front one is bigger than the second one there. Okay, so what I might like you to do here, because remember I said the stem and leaf plots, people get a little bit confused, particularly the back-to-back. So maybe in the next to this positive skewed description, we'll put a picture of the stem and leaf. So say I'm just making these up. So if we have a positive skewed stem and leaf, this will look like that. Okay, if it's on the back side, it will look, all the data's at the start and then it tails off. Okay, and then maybe over a negative skewed, you can draw the same. So what it will look like, you have a little bit of data and then all the main data is at the end. Okay, so that is, so just so you've got them all in one spot. Okay, and then you can see there's the tail at the start and then it goes up. And here's the tail at the end. Okay, so that's for a stem and leaf. If we've got it all in the same spot, we can just go and refer to that in our tests and exams, etc. Okay, question 2. The weather station also records the daily maximum temperatures. So this isn't an exam. There was obviously, they were talking about the same theme, but you know in exams there's generally not consequential, so I can generally pick up at any stage in the question. So if you don't understand maybe the question before, even though the theme of the question is remaining the same, you can probably have a go because they'll use all new stuff. So the 5-number summary for the distribution of maximum temperatures for the month of February is displayed below. So here we've got our 5-number summary. There are no outliers in this distribution, so they've told us that. Use the 5-number summary to construct a box plot. So this is quite easy. You just go and pop them in. So we've got 16, which that's where my thing. Q1 is at 21. So I'll draw a line. So the tail's going out there. The median's at 25. So here's my first box. The Q3 is at 31. And the maximum is at 38. So there I've drawn in my box plot. So in an exam, that's how you'll be asked. In a SAC, you will be asked to draw probably the whole thing, including they might give you a number line, but they might not give you the axes labels. So make sure you're adding those things in. That's in a SAC. In an exam, not so much. So if we looked at this one, just before we go on, what type do you think the shape is? What do you think the shape of this one is? I reckon more positive. I think this bit is here is a bit bigger than that first bit. So I'm going to say positive skewed. So when you're asked to describe them, this is what you generally have to do. The centre, what do we quote when we look at the centre? Someone said it. Median, thank you. So you quote the median. So you say the centre, the median is at 25. Okay, so you quote the centre, or you say the centre is at 25. And then we probably should have written with our shape no outliers when we're describing. And then also we might be asked to talk about the spread. Okay, so we could use the IQR. So you could say the IQR is equal to, now it would be 31 minus 21, so that's 10. Or you can use the range, which is 38 minus 16, which is 22. Okay? And there's your commenting. That's you describing the distribution. Now, why would we use the median for the centre? So the median we're going to use for a measure is used for the measure of centre. Why? Do you know? Yeah, good. So we're going to use there's no outliers in this one, but it's skewed data. So the median is used to measure for the measure of centre because the data is skewed, and definitely if it had outliers, we would definitely be using the median. Okay? So that's why they might ask you, so the median would be used. And same with the IQR. We'd use the IQR for measuring the spread because it's skewed. So remember, IQR and the median are resistance statistics. So they're good for skewed data or data with outliers. All right. Okay, so here we go. So then we've got our box plot shows the distribution of forearm circumference in centimetres for 252 people. So right there up here, they've given me the N. So I know N is 252, which we might need. Now, the question down here, the percentage of these people. So remember when I said, so when you see percentage, I want you to write the amount over the total times 100, and then already we can see it says of these 250 people. So when you see of, that's telling you the total. So which total we're using, so we're using all of them. The people with a forearm circumference less than 30. And so if you go and look at 30, 30's here. 30 is at Q3. Okay, so that's the third quarter mark. So what you might need to realise is that this box in here holds 25% of the data. So does this box, and then so does that, all the rest of it to the left, because this is Q1, holds 25%, and then all the rest of it there holds 25%. So if they're saying how much is less, I've got all of those 25%, which is 75. So the percentage of these people, so yeah, we don't need to find the percentage, we need to use it. We just have to say 75. Sorry, we didn't need to find it. Okay, so just be careful with that. So just remember with your box plots that this bit is 25%, even if it's got outliers, that's 25%, that's 25%, and that's 25%, okay? All right, going. The box plot display the distribution of maximum daily temperature for the months of May and July. Okay, describe the shapes of the distributions of daily temperature, including outliers for July and May. So just be careful. So the first one, we're going to look at July. So that's here. So what do you think the shape is there? Have a look at your diagram. What's this one's shape? We've got a small box, then a large one. Positive. And does it have a outlier? Yep. So we'll say positive skewed with outlier. And then if we look at the May, what do we think May is? Symmetric. Yeah, symmetric with no outlier. So we need to say yes or no, so with no outliers. If you don't state it, you're telling them you don't know. Okay, so you have to show. So now it says up the next question, it is determine the value of the upper fence for July. So you first of all write your formula for upper fence, which is Q3 plus 1.5 times, I'm just going to write IQR, but I'll write it like that. Okay, so then we'll pop in what that data is. So for July, Q3 is 11, yeah, minus Q1 which is 8. So I'll have 11 plus 1.5 times 8, which equals, so 15.5 is the upper fence. Okay, and you can leave it like that. Now, these last ones, they're always going to do these, and these will be the type of questioning on a SAC. Use the information from the box plot to explain why maximum daily temperature is associated. So when you said is associated with the month of year, so just so you know, if there is an association, there's a difference. There will be a difference. There will be a difference. And so what I mean by that is, look at the medians. So you could look at anything, but mainly we look at the medians. So it says, using the information from the box plot, explain why maximum daily temperature is associated with the month of the year. So you can say there is an association because the median of May at, what I'm going to say, what is it, 14.25? Yeah, is higher than the median of July at, what was July, 9? Okay, so that's what I'm going to write.